Three different project scheduling techniques are a topic of this video. First, deterministic schedule. Second, probabilistic schedule. Third, schedule risk analysis. Excel is front-end program to provide scheduling input and to present the outcome of back-end program. Back-end program is Python, characterized with object-oriented program. Let's introduce overview of deterministic scheduling. Durations for activities are deterministic in nature and thus each one is allocated a single value estimation. The estimated values roll up to the project level to define project duration. The statistical tool generally used is critical path method. The schedule developed is a network of activities linked by dependencies, represented by Gantt chart. Now explain main steps in creating the deterministic schedule. Schedule input data are populated on Excel with output ranges are reserved. Make 3 tiers schedule template. Perform critical path analysis and write its outcome on Excel. Draw Gantt chart. Let's move to details of Python programming. Create a Python module on Visual Studio Code. Import libraries required such as NumPy, Pandas, Excel Wings. Define a class for CPM algorithm. Assumptions are made inside a docstring. Till the assumptions are released, the algorithm is theoretical, yet to be realistic. Define init function which is activated when the class is instantiated. To connect Python with active Excel using Excel Wings. And store common variables. Clean up Excel sheet by removing previous run. Read Excel data using Pandas read Excel method. Data validation is yet to be programmed. To make a schedule realistic, project non-work days are to be reflected into the schedule. This will be done next time. 3 tiers schedule template is created by instantiating the schedule template class and calling timetable method. The basis of deterministic scheduling is wrapped into a wrapper function. This differs, depending on displaying Gantt chart or not. Deterministic schedule is based on activities single period, which is deterministic in nature. Project period function returns the data of column named period. Activities predecessors in case of multiple are specified inside a single cell on Excel, separated by comma. It is necessary to make one predecessor to one successor relation to facilitate programming. This is done using strings split function and nested list comprehension. In addition, predecessor and successor's activity index are found and form the 4 columns data frame. Early schedule is calculated along the forward pass, starting from project start activity. Activity is allowed to start only after all of its predecessors are finished. This requirement is fulfilled by using max method. Late schedule is calculated along the backward pass, starting from project end activity. Activity has to finish before earliest successor starts. This is fulfilled using min method. Project end date is decided and fixed by project team, but this program assumes that project end date is same as that calculated in early schedule. Late schedule minus early schedule of activity gives float. Plus float implies that the activity can be delayed by the amount of float without impact on project overall schedule. Negative float is the other way round. Write CPM outcome on the Excel using Excel Wings. CPA wrapper function is developed to include all the involved processes we have discussed by now. CPA wrapper function without Gantt chart is made separately. This function is conceived for schedule risk analysis to optimize program performance. Simulation run 2,500 times with Gantt chart for each CPA takes much longer than without. A class named schedule template is defined. Start from the month of project start date. Extend the number of months you can specify. Top layer for year, month. Middle layer for weekday. Bottom layer for dates. Remove the existing schedule template and reformat Excel sheet. 3-tier timetable data are created for top, middle, and bottom layer. The data table of data frame type is written in the designated range of the Excel worksheet. Multiple cells of top layer need to be merged for each month. We get the number of days of each month using month range method. Finally, we finish formatting of schedule template range including Gantt chart range. A class named Gantt chart is defined to display Gantt chart for early schedule and late schedule, referring to the schedule template produced. Compute start column and column width for every activity's early schedule. Add shape, rectangle, using add shape method, to the position. Critical activities are highlighted. Dependency is depicted using elbow type connector. Add connector method is adopted to connect begin connect bar to end connect bar. Compute start column and column width for every activity's late schedule. Add shape, rectangle, using add shape method, to the position. The late schedule bars are sent to back to allow connectors to be clearly visible, using z-order property. We are running the Python script we have discussed. Instantiate class basic CPA. Implement function start CPM of the new instance SCH. CPA function follows with activity period as parameter. The second scheduling method is probabilistic scheduling. Probabilistic scheduling involves same activities as in deterministic scheduling. The only difference lies in the way of estimating duration. The estimation is 3 points estimate, pessimistic, optimistic, most likely for each activity. Each task duration is assumed to have a beta probability distribution. According to this distribution, the expected duration and variance of the task completion can be calculated. PERT is a statistical tool for project management, analysis, and representation of tasks involved in completing a given project. Now explain main steps in creating the probabilistic schedule. Activity, predecessors, and project start date are same as in the deterministic schedule. Predecessors and project start date are not necessary to be repeated on the probabilistic worksheet. Each activity's 3 duration estimates are provided to calculate the expected activity duration, according to the beta probability distribution. Produce schedule template consisting of 3 tiers. Perform critical path analysis. The activity period in probabilistic scheduling is the mean of 3 duration estimates according to beta distribution. Draw Gantt chart on the schedule template produced. Tkinter form pops up. User selects option for probability distribution chart, probability percentage or project completion date. probability distribution chart is produced. 3 graphs are in one chart: density probability distribution, cumulative probability distribution, and probability prediction. Let's move to details of Python programming. Create a new Python module for probabilistic scheduling program. Import module where superclass is defined. Import libraries required for probabilistic scheduling program. Define a class with superclass to be inherited. The new class will inherit superclass methods and override its method and attributes. Define init function which will be activated when the class is instantiated. Read Excel data on the worksheet named Probabilistic. And override superclasses variables. For example, target cell is changed to G3, not E3. Calculate activities mean of 3 duration estimate as activity period. The activity mean duration is used to estimate project duration through the critical path method. The calculated activity mean duration is passed to superclasses function, CPA. Implement critical path analysis. Write analysis outcome on the worksheet. And display Gantt chart. Critical path analysis result is the basis to find elementary data essential to analyze probabilistic schedule. Project overall duration, mean value, and standard deviation. Need to take note that the probability that the project can be completed within the expected project duration is 50%. Create a form to allow users to provide requirement for distribution chart. 6 frames are designed using the frame widget and the grid geometry is used as geometry manager. Use entry widget to customize project title. 2 radio button widgets are used to implement one of 2 selections, either completion probability % or predicted completion date. Selection of % radio button is associated with callback function to enable % entry widget and disable date picker widget. Selection of date radio button is associated with callback function to enable date picker widget and disable % entry widget. The callback is detailed in the function named radio cell. Percentage entry widget is placed in frame 3 and entry value is to be between 0 and 100. If value is correctly entered, OK button is enabled. Date entry widget is placed in frame 4. You can select a date out of project completion distribution dates. 3 color choosers are laid out inside frame 5, each 4. Density probability, cumulative percentage, prediction %. Once OK button is enabled, press the button to activate Create Per Chart function. Display the form using main loop method. Probability statistics calculation and the form creation are wrapped in a wrapper function named Per Chart Data. Now we are discussing how to create probability distribution chart based on analysis of CPA run. The first thing to do is get the data entered or confirmed in the form for use in probability distribution chart. Use cget and get method. Consolidate data for chart, category X values, primary Y values, secondary Y values. Category X values are date values covering ±3 sigma. Probability density refers to primary y-axis. Cumulative % refers to secondary y-axis. Probability percentage prediction refers to secondary y-axis like cumulative %. Let's start to create project completion probability distribution chart. Create a new blank chart using Charts Add method. Chart position and size are provided. The chart object is defined with Chart API. Draw graph for probability density distribution referring to the primary y-axis. Chart type is stacked column chart. Draw graph for cumulative percentage referring to the secondary y-axis. Chart type is line chart. Draw a tiny column at the date corresponding to prediction probability percentage. Chart type is stacked column chart. Axis object is used for chart axis design such as axis title, maximum scale. The first argument represents axis type, 1 for x-axis and 2 for y-axis. The second argument represents y-axis type, 1 for primary and 2 for secondary. Set vertical and horizontal grid using setElement function. Define a wrapper function consisting of all sub-functions, starting from getFormData. This function is called by pressing OK button on the form. Now we are running the Python script we have discussed. Instantiate an object of the class BasicPert. Implement critical path analysis. Probability distribution chart data are consolidated. Create PERT chart. The third and last scheduling method is schedule risk analysis. Monte Carlo simulation is a comprehensive range of computational algorithms that are determined by repeated random sampling to achieve numerical results. The schedule risk analysis is required to run critical path analysis as many times as specified, for example, 2,500 times, by selecting random duration for each risky activity from its range in according to triangular distribution. Each simulation run result is stored in data frame and the data is reviewed, analyzed to determine the entire pattern of possible completion dates for the project and/or selected activity. Now explain main steps and perform the schedule risk analysis. Activity, predecessors, and project start date are same as in the deterministic schedule. Predecessors and project start date are not necessary to be repeated on the schedule risk worksheet. Each activity's 3 duration estimates are provided: optimistic, most likely, and pessimistic. Tkinterform is designed for user to provide requirement for program run and its output. Enter program run requirement. Firstly, how many simulations to run. Secondly, binning requirement for probability distribution chart. And p% value to be highlighted on the distribution chart. As a default, 3 visualizations are made: project completion distribution, criticality index, and schedule sensitivity index. Regarding activity completion distribution, need to determine whether to view or not. If you like to view, select an activity of your interest. Whether to view Gantt chart during simulation run, you can select an option to view or not. Default is not to view Gantt chart, keeping in mind that Gantt chart viewing for each simulation run takes much longer in program run, due to interaction with Excel for each simulation run. Perform critical path analysis with randomly selected activity period for the number of simulation count. For each run, Random activity duration is selected from the range of 3 duration estimate according to the triangular distribution. Draw Gantt chart for each run provided the option is selected. 3 charts and data table are generated. Project completion distribution chart. Criticality index. Schedule sensitivity index. Activity completion distribution chart is viewed for the selected activity, provided that the related option is selected. Let's move to details of Python programming. Create a new Python module for schedule risk analysis named sratheory.py. Import superclass, basic CPA, from the module, deterministic_theory. Import libraries required for the schedule risk analysis program. Define class, named basic SRA. Inherit superclass, basic CPA. The basic CPA class as discussed earlier deals with critical path analysis and Gantt chart. This way, CPA and Gantt chart associated functions are not required to be repeatedly written in the new class, basic SRA. Whenever a class is instantiated, a call is made to the __init__ function defined in that class. To define interface between Excel and Python using slwings. To read Excel data from a worksheet, schedule_risk. To store new variables or override variables of the superclass. To call the createForm function. This is implemented when a new instance of basic SRA object is created. Now let's develop a tkinter form to collectively get data required for program. Starting from top-level widget. Create top-level widget, which is normally referred to as the root, in order to provide a separate container for other widgets, such as frames. On the top-level widget, we define form title, form size, and form position in the monitor. Five frames are designed to hold a group of widgets in them, each. The 5 frames are laid out using Grid Geometry Manager. Frame 1 contains a label and an entry widget, to customize project title. Balloon widget is to display help information when the cursor is placed over a widget on the screen. Frame 2 contains 3 labels, and 3 entry widgets to enter data required, as the basis of program run. First, simulation counts between 100 and 2500. Another 2 entry widgets in the frame 2 are bin counts between 20 and 40. Prediction % between 10 and 100. The acceptable data entry enables OK button. Otherwise, OK button is disabled. Frame 3 contains 4 label widgets, 1 check button and 1 combo box widget. Label widgets are used to display default visual representation of the program. Project completion distribution, criticality index, sensitivity index be created. 1 check button widget is to check whether or not the activity chart and data table is required. Once check button is checked, combo box widget lists down all the activities, one of which you can select. Frame 4 contains 2 radio button widgets. Using the radio buttons, you can decide whether or not create Gantt chart in every simulation. Frame 5 contains 2 buttons widgets. OK button is enabled with green color when inputs are made correctly. Press the button to invoke callback function. SRA main without Gantt function when Gantt chart is not required during simulation run. SRA main function when we do not have to view Gantt chart for every iteration. Display the form using main loop method. Get the data entered or confirmed in the form. The data become the basis of schedule risk analysis program run. Use get method. 3 durations estimate for each activity is given like probabilistic scheduling. Activity period is taken over the range of 3 duration estimate, along the triangular distribution, for the number of simulation. Use NumPy's random triangular method. Activity period data of the number of simulation are stored in list, then transformed to a data frame. A main function is developed to wrap the functions programmed to do CPA, along with writing each result on Excel, followed by Gantt chart. Gather all the CPA run data. The class SRA result is instantiated and the whole simulation run data are analyzed, and its result is represented in completion distribution pattern, and activities characteristics, in SRA result main. SRA main without Gantt function is same as function SRA main, except that Gantt chart is not displayed during simulation run. A class, named SRA result, is focused on review, analysis, of whole simulation run gathered in the class basic SRA. Then present the entire pattern of possible completion dates, and activities to be managed, in terms of project risk mitigation. When the class is instantiated, init function is executed. 2500 data frames is made into one data frame using concatenate method. Calculate statistics associated with project finish dates. Mean. Standard deviation. Confidence interval. The project finish dates are aggregated daily over the range from their minimum to maximum. Occurrence. Cumulative count. Cumulative percent. Make a completion date table, corresponding to 5 to 100% with 5% interval. The table is embedded in Excel sheet side by side of distribution chart. Binning is made to group a number of continuous finish dates into a smaller number of bins. Default number of bins are 20 with maximum 40 in this program. Data frame of finish dates distribution by binning is made. The distribution chart is created, based on the data frame made by binning. Probability percent is highlighted with vertical line. This is made using stacked column chart. Find the finish date close to probability percent required and all the other finish dates cumulative percent is set to 0. The criticality index expresses how often a particular task was on the critical path during the analysis. Tasks with a high criticality index are more likely to cause delay to the project, as they are more likely to be on the critical path. The schedule sensitivity index measures both the probability and the impact in activity times. Activities standard deviation along with criticality index is considered. The SSI is known as the most reliable sensitivity metric. Now ready to discuss how to create a distribution chart. Create a new blank chart using charts add method. Chart position and size are provided. The chart object is defined with chart API property. Consolidate chart XY data values. Category X values. Primary Y values. Secondary Y values. Display occurrence by binning. Chart type is stacked column chart along primary Y-axis group. Display cumulative percent by binning. Chart type is line chart along secondary Y-axis group. Draw a tiny column at date x-axis value, corresponding to prediction probability percentage. Chart type is stacked column chart referring to secondary y-axis group. Axis object is used for chart axis design such as axis title, maximum scale. The first argument represents axis type, 1 for x-axis and 2 for y-axis. The second argument represents y-axis type, 1 for primary and 2 for secondary. Set vertical and horizontal grid using set element function. Write the distribution data table on Excel sheet at the right of the distribution chart. Distribution chart and data table is discussed, and now let's look at how to make tornado chart. Create a new blank chart using Charts Add method. Chart position and size are provided. The chart object is defined with Chart API property. Create two tornado charts, one for criticality index, the other for schedule sensitivity index, one after another. The chart type we adopt is clustered bar chart, showing highest top 10 elements. Define two wrapper functions, one for project, another for the selected activity. This class's methods are wrapped into SRA result_main wrapper function. In order to run the SRA program, instantiate an object of the class basic SRA to pop up the form we have discussed. Once OK button is enabled and pressed, whole schedule risk analysis process is implemented. As a wrap-up, 3 scheduling techniques were discussed. Excel is front-end program for scheduling input and presentation of Python-based program output. All 3 techniques should go through critical path analysis, if schedules are to be logical. The CPA algorithm is kept in a class for deterministic schedule. The probabilistic and schedule risk analysis classes inherit the class in the deterministic schedule module, to take advantage of its CPA functions. The CPA algorithm is yet to be realistic. Realistic algorithm will add the functions to include non-work days, other dependency logic than FS, finish to start, time lag and so on in the near future. Thank you for watching.